Right. So a shell is similar to a washer. They're both cylinders with holes in them, but they're a little bit different in the formulas that we're going to use. So if you look up here, this is basically kind of what we started with when we talked about washers. We're taking the volume of the big cylinder minus the volume of the small cylinder. That's kind of what we started from. And what we did for washers was we factored out the pi and the h. So we had pi times big R squared minus little r squared times h. And that's basically our formula that we use to find volume using washers. We take the definite integral of this from a to b. But we're going to kind of transform that a little bit into a slightly different formula for shells. And I wouldn't expect you to be able to do this part or like come up with this, and you don't have to. It's just showing you the transformation from this formula to the one that we're going to use for shells. So first thing we would do is we can factor the difference of two squares here. We have pi times big R plus little r times big R minus little r, which I'm sure you could all do on your own. But this next step, you wouldn't necessarily think to do it. What I'm going to do here is multiply by 2 and by 1/2, which you might think is crazy, and maybe it is a little bit, but it gets us a formula that kind of makes sense with this. If we look at this portion of our formula, 1/2 times big R plus little r, what does that represent? Something to do with the radius, right? No, because the small radius is here, little r, and then big R. But if we add those two up and then multiply by 1/2, there we go, good, average. Right, so this is our average radius. And so 2 pi times our average radius. The big R minus little r, if we subtract those two, what we're getting is this little measurement right here in our shell, which we're going to call the thickness of the shell. Right, so the thickness of that shell, and that thickness is going to be very small. That's what makes the difference between a washer and a shell. That thickness right there is our dx or our dy. If you look at this, it's going to be a very small measurement, whereas the height for the washer or disc, the height was very small. Here we have a larger height. Alright, so basically, shell is kind of like the tall, skinny cylinder with a hole in it, and a washer is a short, flat cylinder with a hole in it. But this is our basic formula that we're going to use to find the volume using shells, except we're going to add the definite integral. So we're adding up all of those different volumes of all those little shells that create that one big solid of revolution. So the volume formula for shells is 2 pi, we'll pull that out in front of the integral, times the definite integral from a to b of the average radius times the height times the thickness. Now, the reason I switched around the height and the thickness from the original formula is because that thickness, like we saw here, that's always going to be dx or dy. So in our integral, that's always at the end. Alright, so this is for a shell. And let's take a look down here, a couple differences and similarities with shells and washers. Shells are a little bit different because instead of being perpendicular to the axis of revolution, shells are parallel to the axis of revolution. So like the rectangle is parallel to the axis of revolution. Whereas discs and washers the rectangle is perpendicular. the axis of revolution. So, easy way to remember it, shell, parallel, they rhyme. And shell is going to be parallel to the axis of revolution. So you can kind of see here this rectangle, we spin that around. If we look at this drawing down here, basically this is our little rectangle spinning around that line. This is going to be our height, right? That vertical distance. Basically the height of that rectangle is the height of our shell. Then the average radius is that distance from the axis of revolution to the middle of that rectangle. And then in this case, it's a dx cut. That's our thickness. Another thing that's different between shells and washers, and it kind of comes down to what we talked about up here, is that for a shell, if we go around the y-axis, we get a dx cut. But with discs and washers, if we went around the y-axis, it would be a dy cut. Right, so that's opposite. So for shells, if we go around the y-axis, it's a dx cut. For discs and washers, if we go around the y-axis, it's a dy cut. And then we'll see the opposite over here. So this is our rectangle spinning around, creates that shell. So our height of the shell this time is kind of on the side, it's horizontal. Average radius is that vertical distance to the middle of that rectangle, and then the thickness for this one is dy. So again, for shells, if we go around the x-axis, it's going to be a dy cut. But for discs and washers, it's opposite.